to introduce yourself, where you're from, what do you do, are you music therapy related? I'm going to put here the newsletter link so that you can subscribe to it and be up to date with any upcoming lectures. Now I'm just going to hand over to Dr. Clemens Maidhoff, Senior Research Fellow at the Cambridge Institute for Music Therapy Research. Thank you.
Yes, thanks, Leo. And thank you all for coming, and also welcome from me. I'm Clemens Maidhoff, Senior Research Fellow here at the Institute, and it's my pleasure tonight to introduce our guest speaker, which is Dr. Yap Sansan, is a music therapist, researcher, and performer whose work integrates neuroscience, clinical practice, and improvisation. And she's a clinician researcher at the University Hospital Tulln in Austria. And she holds a PhD from the Anglia Ruskin University in Cambridge. And her research focuses on how interpersonal synchrony, such as heart rates and movements, shapes therapeutic processes in neurological rehabilitation. And with that, I hand over to you, Sansan, and we're looking forward to your presentation.
Any feedback?
Yes.
Yes? Okay, great. So hello, thank you again for being here this evening. My name is Yap Sansan, and I'm a clinician researcher in music therapy, specializing in neurorehabilitation. And last October, as mentioned, I have completed my doctorate at Anglia Ruskin University under the supervision of Jörg Fachner, Clemens Maidhoff, Gerhard Tuchek, and Wolfgang Schacher. In this lecture today, I would like to discuss synchrony and share the findings from my dissertation. And my primary focus will be on heart rate synchrony and the interaction between patients and therapists during segments of both high and low heart rate synchrony. And then finally, I will highlight the moments of interest as identified by the music therapist. So it has been observed that the world around us exhibits a remarkable tendency towards synchrony, where various elements of nature come together in harmonious coordination. A striking example you see here, it can be witnessed on Brighton's Pier, where during the winter months, thousands of starlings gathered in the evening sky, and as dusk falls, these birds engage in a captivating aerial display, performing an intricately synchronized dance that leaves onlookers in awe. I haven't seen one of them knock into another one, so they are quite good. Their movements create a mesmerizing spectacle as they twist and turn in unison, resembling a living wave or a constantly shifting cloud. Or perhaps the stunning scene along the rivers of Southeast Asia, where thousands upon thousands of fireflies would gather. Without a conductor, the fireflies lit up in a synchronized manner, where each of them sends and receives signals continuously, influencing the rhythms of others and being influenced in return, as described in Stephen Strogat's book. The term synchrony comes from ancient Greek, where sync means together and chronos refers to time. Therefore, synchrony signifies the sharing of common time. This man on the left you see here with long curly hair, his name is Christian Huygens, and he was a famous inventor and scientist. He wrote about the sympathy of two clocks already in 1665. After he was forced to stay in bed due to an illness, and since binging on Netflix was not possible back then, he took notice of the two pendulum clocks which were hanging at the end of his bed. The clocks were hanging from a single wooden beam, and then soon he observed that their sounds were always heard simultaneously. And then he discovered that they would eventually come back to synchronization after he had disturbed them. He realized that the clocks were able to synchronize because of the motion of the flexible beam that they were hanging on. So both clocks could feel and adjust to each other through this free medium. Similarly, humans have a remarkable tendency to align their physiology and behaviors with others during observation or during interactions. Synchrony refers to the relationship that involves at least two units of analysis, whether between two modalities within an individual or between two individuals, which is known as interpersonal synchrony. Within this context, the coordination of physical movements between pairs is known as nonverbal synchrony, while the dynamic coordination of physiological processes such as heart rate is called simply heart rate synchrony. And why study the synchrony of hearts, you may ask? You see, when the ancient Egyptians prepared their loved ones for the big journey to the afterlife, they would place the internal organs into these containers during the mummification process, which you see on this slide. The jackal-headed one will protect the stomach, the baboon-headed one is called harpy, will watch the intestines, and the falcon-headed one, the lungs, and the human-headed, the liver. Now, what about the brain? The ancient Egyptians thought it was just as useful as a screen door on a submarine. So they just shove a hook up the nose, shake things around a bit, and then toss it out. But what about the heart? The heart, that is the VIP ticket to the afterlife. The ancient Egyptians believed that it was the connection between this life and the next. The heart was the witness to a man's life, and so they make sure to leave it in the body. Therefore, personally, instead of studying the brain, sorry, Clemens, I would put my money on the heart. Jokes aside, researchers propose that the ability to synchronize with others is fundamental to us, social beings. For the individual, synchrony helps us recognize who our allies are and increases our chances of survival into adulthood and beyond. As a group, synchrony works like a kind of social glue that fosters bonds and allows us to coexist harmoniously. It almost seems like we might be born with this ability to synchronize, and we certainly begin to hone this capacity when we engage in baby talk. In fact, Ruth Feldman and her fellow researchers found that the moments of vocal and affective synchrony between mother and infant dyads were matched to the synchrony of acceleration and deceleration of heart rate. And even before a child is born, heart rate synchrony has been found between mother and fetus in both directions of influence. This may explain the connection between fetal heart rate fluctuations and the mother's physiological and psychological state. It may also explain how it is possible for pregnant mothers to perceive certain changes in their unborn child. Heart rate synchrony exists also between couples, which may point to a mirroring process of emotional contagion and joint experience. An interesting HRV, this is heart rate variability study, showed that happier couples may synchronize less often or for a shorter period during disagreements than unhappier couples. In addition, their heart rate variability also synchronized more closely during disagreement when the partners had less sleep. So for the sake of your relationship, do get more sleep. Heart rate synchrony has been observed as well among larger groups of concert goers and participants in group drumming settings. Heart rate synchrony was even observed between performers of a fire walking ritual and the spectators who were related to them, but not observed in unrelated spectators. Highlighting, these studies highlight the association between heart rate synchrony and empathetic responses, affectivity, and personality. In clinical psychotherapy settings, heart rate synchrony has been studied as early as 1956. Coleman, Greenblatt, and Solomon reported significant correlation between heart rate of the patient and the therapist. They suggest that heart rate synchrony was associated with greater focus on the client. And then in 2020, Chacha and Meyer found that heart rate synchrony between therapies and patient diet in clinical settings was beyond random by comparing actual synchrony to a pseudo-synchrony. They reported that heart rate synchrony was associated to therapy's alliance and progress ratings. And 2 years before, in 2018, Kodama et al. Found in their single session study that heart rate synchrony was higher in the initial phase and then gradually decreased during the session. They suggest that therapies leading in heart rate synchrony reflected the behavior of therapists collecting information and giving advice. High heart rate synchrony also coincided with observation of the therapist showing empathic and attentive behaviors. And in 2022, Conroy et al. Found in their study consisting of 8 sessions of emotionally focused therapy for couples, they found that couples' heart rate synchrony increased instead over time. So instead of going down, it increased over time, and significant heart rate synchrony occurred during the sessions where themes like attachment injuries, loci of pains, distress in the relationship, bonds, and the couple's desire for intimacy for each other were discussed. So the authors concluded that the greater empathic response produced greater physiological synchrony. And what about in music therapy? Would there be any heart rate synchrony between the patient and the music therapist? Would synchrony be more than just coincidence? And what could be happening on the therapeutic interaction level when there is a synchronization of heart rate? And these were the questions I asked. Investigating heart rate synchrony can offer valuable insights into the mechanism underlying music therapy. In 1998, Neugebauer and Aldrich investigated heart rate of 2 people improvising in a situation akin to music therapy setting. There were 11 dyads consisting of 11 healthy participants and 1 music therapist. Special moments were selected by the music therapists, which will have musical relevance based on communicative interaction or musical events such as moments of musical interrelationship, initiative for musical change, mutual changes in the playing, changes in tempo, dynamic, mood, etc. And heart rate data was plotted graphically, and then a physiologist examined the data to identify areas of interest for physiological changes. The authors compared the data graphically for convergence. The results demonstrated clearly that heart rate changes is linked to relational and communication process. They found that more heart rate synchrony occurred during music activities than other activities such as talking or resting in between. Neugebauer and Aldrich concluded that the behavioral patterns of the dyadic heart rates and the dyadic interaction showed that they were structurally isomorphic. So what emerged during music intervention was not only a musical contact, but also a physiological contact. And I quote, "Perhaps this is the basic of human empathy, where 2 hearts beat as one." Well, at this point, I would like to discuss my interest in heart rate synchrony from an autoethnographical perspective, as it is very likely stem from the significance of the heart in my culture. The heart, Xin, which is the first and third character, Chinese character in the middle of this slide, is the locus of mental and emotional life. All written characters pertaining to thoughts and feelings will include the radicals of sin. That sin will become a part of this word. The heart is essentially where one's true self exists. So the quality of the relationship is defined by the degree of knowing each other's hearts. The optimal interpersonal relationship would be when 2 hearts are linked, 心连心. Empathy is the connection of 2 hearts where feelings and thoughts flow from one heart to the other. Hence, the spatial closeness between the hearts represent the closeness of the relationship. And when the relationship is profound and empathic, it is expressed as two hearts bumping into each other, 心碰心, which is these letters that are written here. As the Little Prince said, it is only with the heart that one can see rightly. What is essential is invisible to the eye. My study, this study, utilizes modern advancement in computational technology to make the invisible synchrony of dyadic heart rate visible and to deepen our understanding of dyadic interaction during music therapy intervention from a physiological level. Heart rate synchrony. So this here on the right is a typical music therapy session. It begins and ends with an unstructured conversation, and then the music therapy intervention occurs between these two conversations. Imagine that both the music therapist and the patient are like Christian Huygens pendulum clocks, each with their own rhythm and functioning as self-oscillating systems. Can the music therapy intervention serve as a medium, much like the wooden beam from which the clocks were hanging, allowing the therapeutic pair to express themselves, listen, and adjust to one another? Would they enter into a process of entrainment, and would this be reflected in their heart rate? Similar to the already mentioned Neugebauer and Aldrich study, our convenience sample consists of 11 dyads too. But it includes 1 music therapist and 11 inpatients from a neurorehabilitation facilities. Our materials included video recordings of single session from each dyad, along with the corresponding heart rate data. As a research group, we wanted to bridge the gap between research and clinical practice by bringing the lab to the clinic and operating under authentic clinical conditions, including the provision of personalized treatment. As a result, the duration and the type of music therapy intervention was not manipulated or restricted, allowing for an organic process to unfold, prioritizing the individual needs of the patients. The dyadic heart rate synchrony was analyzed using windowed cross correlation in 30-second segments with a 2-second lag, with the RMEA package in the RStudio environment. We compared the actual heart rate synchrony to pseudo-synchrony obtained through between dyad shuffling, and we examined the occurrence of the 4 highest heart rate synchrony segments, we call it sync, SYN, and the 4 lowest heart rate synchrony segment, which is N-sync, NSYN, as well as moment of interest segments selected by the music therapist. Then we looked at the characteristic of the interaction of these segments using qualitative content analysis, guided by Professor Raglio's music therapy coding scheme and the Kremser music therapy session reporting protocol. In the last figure here, you will see the yellow bars, which are the sync, and the green bars are the end sync, and the black ones are the moment of interest segments. The results. We found that actual heart rate synchrony was significantly greater than pseudo-synchrony, which suggests that heart rate synchrony between the patient and the music therapist during music intervention was not a matter of chance. Furthermore, patient leading during heart rate synchrony was also significantly above randomness. We also observed that sync and moist segment appeared more in the second half of the intervention. If you look at the diagram on the right, you will see that the orange and the black were kind of more steered towards the second half. Visually, we saw it, and yeah. And whereas N-sync, the lower synchrony, the lower synchrony segments were more equally distributed. Actually, they were equally distributed. Indeed, heart rate synchrony was significantly positively correlated to music therapy intervention duration. We observed that dyads with an average intervention heart rate synchrony above 75 percentile had music intervention for at least 25 minutes, When we divided the segments into 5 minutes block on the right, we found that the mean heart rate synchrony of the block at the 20th to 25th minutes was the highest compared to the other blocks. It also contained the highest heart rate synchrony value overall and the greatest number of top 5% heart rate synchrony values. The results indicated that the duration of music therapy interventions may significantly impact dyadic heart rate synchrony. This raises the question of whether music therapy sessions shorter than 25 minutes might be less effective, especially if achieving a high heart rate synchrony is a desired outcome. This consideration could be important for resource planning in clinical settings and supports the argument for not reducing the duration of therapy sessions. And with the MaxQDA program, here you see a screenshot of the work. We analyzed the dyadic therapeutic interaction of the sync and n-sync segments. In total, there were 44 sync segments and 44 n-sync segments and 50 moment of interest segments. 39 codes were used. On the right, you see the code distribution and yeah. The qualitative analysis of the videos revealed that during sync segments, patients were more aware of their surroundings, and the therapy interaction reflected shared interest between the dyads. They seemed more connected. Additionally, the dyads listened to each other more frequently and appeared relaxed. In contrast, during the n-sync segments, there was a noticeable reduction in connection within the dyads during the therapy interactions. They showed less alignments with their attention, and their attention was primarily focused on the activity at hand, not on each other. Patients appeared to turn the focus inwards, while the music therapist was observed to be supporting and creating a safe space for them to process their emotions. Physical manifestation of connections, such as attuned movements, were much more prevalent in the sync segments compared to the n-sync segments. Furthermore, patients demonstrated greater independence and initiative, which is empowerment, during the sync segments. And comparing the types of music therapy intervention occurring during high and low heart rate synchrony, we noted that the most common type of music intervention overall was improvisation. Improvisation was present in both sync and non-sync segments. For sync segments, the second most common intervention was preparation/transition to intervention, and then followed by drumming and voice work. For non-sync segment and sync segment, the second highest frequency was also preparation transition, while the third highest was shared between drumming and listening to preferred music. Now I would like to talk a little bit about a moment of interest. Various terms have been used to describe these powerful and meaningful experiences that encompasses a pivotal function which provokes change in therapeutic process. We define moment of interest as selected target sequences in a time series of clinically relevant events that were recognized and selected based on personal and/or professional preference and interest, by Wagner et al., 2019. As usual in clinical practice, the moment of interest segments were intentionally selected for their therapeutic significance and transformational potential from the music therapist perspective. And from our data, we found that these moment of interest segments will focus on relational connection, immersion of the patient's musical self, patient's emotional expression and processing, patient's insight and awareness, as well as patient's cultural and personal identity. And we found that heart rate synchrony during moment of interest was not significantly higher than the average of the intervention. And the moment of interest segment occurred mostly equally between sync and non-sync segments. This result indicates that moments which the music therapists found interesting or important for the therapeutic process were not steered only towards high heart rate synchrony, which implies that low heart rate synchrony segments shouldn't be ignored. Observation of moment of interest segments showed positive mood characterized by emotional alignment within the dyads and active participation from the patients. There were also instances where patients appeared withdrawn, indicating a need for self-regulation, during which the music therapist held space for processing. Furthermore, patients experienced empowerment, discovering new insights, of having revelations. These traits are consistent with how authors define meaningful pivotal moments. Current literature has also suggested that successful interpersonal coordination requires dyads to dynamically move towards and away from each other. And these dynamics are both complementary and adaptive. It is very interesting to note that 27 of the 50 moment of interest segment overlapped with either very high synchrony or very low synchrony segments, bearing in mind that each of these segments has only 30 seconds each. Considering that the total duration of music intervention material that we have lasted 282 minutes, this is like about 6 hours, I think. This could suggest a connection between moment of interest and the very high or very low physiological synchronization of heart rate, and the manifestation of dyadic interaction was detectable physiologically during moment of interest. Just as the study from Neugebauer and Aldrich suggested that the patterns of cardiovascular behavior and interactions were structurally isomorphic. So the conclusion, dyadic heart rate synchrony was detected during the music intervention, indicating a greater focus on the patient and possibly positively impacting session level outcomes. Music therapy intervention duration was found to influence the level of heart rate synchrony, and the results of this study indicated at least a duration of about 20 to 25 minutes. We observed that patients showed more empowerment and external awareness in segments of high heart rate synchrony. The dyads appeared more connected and even manifested the connection as attuned movements. They listened to each other more often and appeared to be relaxed. In neurorehabilitation settings, where music therapy goes, often comprised of physical, cognition, language functional components, where traits like motivation, positive experience, and resource activation and overall participation is considered to have rehab potential. Therefore, high dyadic heart rate synchrony seems to be indeed desirable. Music therapy intervention was not only able to act as a free medium for the meeting of the hearts, it was also able to provide a space for dyads to dynamically move towards and away from each other to build interpersonal synchrony. What insights could heart rate synchrony offer? Well, interpersonal synchrony is a dynamic and adaptive process specific to each dyad. Within the framework of the music therapy, a nuanced understanding of the heart rate synchrony could shed light on how therapeutic relationship manifests at a physiological level. This knowledge serves as a crucial biomarker, enhancing our grasp of mechanism of change and potentially advancing clinical practice. Research indicates that heart rate synchrony may reflect shared experience, empathic responses, and personality traits. In our study, focus on neurorehabilitation population, we identified a correlation between heart rate synchrony and the duration of the intervention. Interestingly, we observed that while dyadic interaction varied during periods of high versus low synchrony, both segments contain what therapists would recognize as moments of interest that signify relational and therapeutic processes. However, many dimensions within this field remain uncharted. For example, how do a patient's specific pathology or the approach of the therapist influence heart rate synchrony? And what kind of implications do high or low levels of synchrony then hold in these various contexts? Investigating the links between heart rate synchrony and other physiological modalities such as EEG, electrodermal activities, and respiratory rate opens up new dimensions in understanding the patient's-therapist relationship. This multimodal approach would bring us closer to a holistic paradigm, allowing for more personalized treatment plans that could enhance the effectiveness of music therapy. Moreover, viewing heart rate synchrony as a biomarker also empowers us to comprehend the experience of the patients who struggle to communicate through traditional means, maybe such as those with disorders of consciousness, for example. The ability to make the invisible heart rate synchrony visible could provide a valuable tool for clinicians to understand the therapeutic process that they are sharing with the patients, and has the potential also to give a voice for some of our most vulnerable patients. So you are going to listen to 2 audio samples showcasing the real-time heartbeats of a therapist and a patient during music therapy intervention. These heartbeats will be represented through the sound of a high wood block and a low wood block. In one of the examples, you will hear a segment of high synchrony and the other sample features a low synchrony segment. As you listen, I encourage you to engage actively by tapping along with the sound. So for example, use your right hand to tap along with the high wood block, and while your left hand tap along with the low wood block. This exercise will help you distinguish between the 2 segments. After you have finished tapping, we will review which samples correspond to the high synchrony and which one correspond to the low synchrony. And following that, we will take a look at the interaction that occurred during the segment of high heart rate synchrony. So, are you ready? So maybe at this point you can put in the chat what you think, which one do you think is the sample with a high heart rate synchrony? Well, about 5 people. Don't be afraid. It's okay. It's quite hard. Okay, so now we've got some disagreement here. Sample 2. Okay. All right. Now we will review. So sample 1 was correct. And let's now watch the interaction during this. Das machen wir schon ein bisschen Sorgen, dass wir nass werden, ne?
Ja.
Thank you very much. And if some of you are interested in exploring dyadic heart rate synchrony, you're most welcome to write to me at the following email address: research, what do you call that? Music therapy at outlook.com. Okay, I will stop sharing now. Thank you very much.
Great. Thank you very much, Sansan. And I guess you can see the clapping hands flying over your screen.
Yeah, and there were a few hearts as well.
Hearts even. Wow.
Yeah.
Right.
Woohoo.
Yeah, and if you have any questions, please just put them in the Q&A box of the Zoom, which you can find in the Zoom taskbar. And we have one question already from Q. Good to see you here. Do you see that, Sansan, the question?
Yes, I believe. Would you read that out?
Yeah, I can. I can try. So thank you so much for sharing such an important and impressive study. This is amazing. I believe that synchrony is incredibly challenging to extract purely we want to look at, as there are so many variables influencing the signals. Speaking of which, I imagine that heart rate data can be highly sensitive to movement artifacts. Were you able to align the movement data with the heart rate signals to isolate the true interpersonal synchrony, for example, shared experiences and empathy between the music therapist and the participants? Or were you also interested in examining dyadic movement patterns and how they relate to heart rate synchrony? Also, I was wondering whether you had a chance to analyze any musical characteristics, such as faster versus slower tempos or other musical features, and how they may have influenced the synchrony measures. So great. Great question, or rather great questions. Feel free to address them.
Thank you very much, Kurim. Yes, what we did look at movement synchrony, but in this study, the setup was that we analyzed movement synchrony before the intervention, 2 minutes before, and then we had the music therapy intervention, and there we analyzed the heart rate synchrony, and then we analyzed 2 minutes immediately after the intervention. And we found that there was an increase in nonverbal synchrony, that is the movement synchrony between patients and the therapist. We couldn't do movement synchrony because calculation or analysis during the music therapy intervention, because if you were to play a drum, your movements will be bigger, and if you were to play the guitar, your movement will be smaller. So it would not be good to compare this. Yeah, and it doesn't mean that when I have a bigger movement, it means that my sound is more critical. It can be I could just play a very wrong small tone to have a very powerful impact, or actually when I remain silent, that is also very impactful as well. No, we didn't examine that, but what we found was that there is no real correlation. We didn't find any correlation, significant correlation in our data between the change in the nonverbal synchrony before and after and the heart rate synchrony. There was no direct connection in this sense. And your second question was if I have analyzed musical characteristic. Yes, that would be a very interesting thing to analyze, but with the 11 samples that I have, it would not be enough because we had many different types of intervention. So I can't say if they were all improvisation, maybe it's easier to compare. But with singing and then with music, also we had dyads who were actually writing songwriting. So it's really difficult to analyze the musical characteristic. What we need is orchestrated research that a lot of us do the research on heart rate synchrony, and then we can put our data together, and then we can put them into different, we can segment them. Yes. Thank you. And there's a second question about, do you want to read that? You did so well.
Yes, Bettina Flater, apologies, says, thank you for a fascinating talk. I have 2 questions. One, did you investigate heart rate variability at all? And second, synchrony decreased after minute 25, it seems. Is that correct? And how do you interpret that?
Thank you for the questions. No, we did not investigate heart rate variability because I think it's too short a period of time to actually think that you can change the heart rate variability. This is my opinion. And synchrony decreased after minute 25, it seems. Because we were working under the conditions of a clinic, we did not have session that lasted, I don't know, more than an hour. Maybe things change after an hour. Maybe things get even more interesting, or maybe things get even more further apart. Just within the context, we were able to find that 20 to 25 minutes that seems to be optimal, or seems to have the highest heart rate synchrony around this time. And remember, this is the music therapy intervention, is not the whole session. The entire session would last 50 minutes or 60 minutes. It's only the one intervention that was between a pre-talk and a post-talk. Yeah. And then the third question.
Third question is from Juan Pedro Zambonini. I noticed that in sample 1, the heart rates drifted out of synchrony once the patient made eye contact with you. What can we cautiously infer from that?
Very good observation, Dr. Zambonini. So I would like to go back to the video. Is it okay? And share sound. Oops, how do I go back? Okay, and all right, to just forward it to the part. It's interesting observation. I also noticed, I also have this because it's also written in the observation. The synchronization parts come in when they started to make music, to, to go faster into it. And then it comes to kinds of stop. At a certain moment, there was, I interpreted that the patient was a bit unsure. Wait, let me stop sharing. The patient was a bit unsure. At first, he was into it, and both of them are into the music. And then after that, at a certain moment, he was not sure, and he was looking up to find some assurance from the music therapist. He was unsure that he was doing the right thing. A lot of patients, they try to do the right thing, especially when it comes to music, and I think this broke kind of the connection, yeah, in this moment. So somebody wrote here, it seems also that the synchrony occurred after the shared laughter. Yes, a humor is a very interesting phenomenon we observe also in the extreme synchronized part. In the extreme synchronized data, we find that humor is one of the most frequent observation.
Great, thank you very much. Yeah, and maybe one or two questions from me. In the meantime, maybe people want to put more questions in the Q&A box. And also, Q mentioned that synchrony is very challenging to extract movement artifacts and other problems. Also with the methods and actually what is synchrony exactly? Are there different versions? How do we measure that, etc.? And one potential confounder, as far as I know, is also breathing, because there's the link between breathing and heart rate. But not a lot of people look at that systematically. Is that correct from you? Or do you know any studies who look at that actually?
I think the study from Chaka and Maya, and as well as the one from Victor Müller from the choir, did look at this. And I think one of them found that there was no connection between the respiratory rate and the heart rate. Yeah.
Okay, yeah.
I recall vaguely something like this.
Yeah.
Yeah.
Okay, because I had to think of laughter, because I assume also that sort of might synchronize the breathing rhythms of the persons, which might then lead to increased heart rate synchrony as well.
And what you were hearing from this audio sample was actually the live beating of the heart. I mean, we're not talking about correlation. We are actually listening to simultaneous beating of the heart. I mean, that is really another level altogether. It's not only that it's synchronized in the rate, but it's also at the same time what our ear can perceive. Yeah.
Mm.
And about the movement, I would like to say that in for our study, the patients did not the both of them were sitting down during the music therapy, so nobody was making no dyads were making movements like exaggerated, very big, yeah. So that would not really be a confounding factor that was affecting the heart rate.
Mm. Yeah, but I was also thinking of in terms of difficulties in recording good data in the first place. Like with EEG, you have easily movement artifacts.
Yeah.
If you have bad luck, you can also get movement artifacts just from the sensors that you're recording the data with. Yes, but on a broader level, and you mentioned the possibility of heart rate synchrony as a potential candidate of a biomarker. So what would you, and you also mentioned we need a concerted research efforts. So what would be your recommendation, where to go from there, next steps, what needs to be done?
Well, I think we have to develop a way of working, a way for clinicians to gather data that is not going to interrupt the way that we work, not going to be a burden to the patients, and easy to operate. I think we need to encourage this kind of investigation, this kind of clinical research, because otherwise you will have very little, or I mean, yes, we need to have more data so that we can actually have different kind of, for example, divide them through their age, divide them by their pathology, and the kind of intervention, whether it was improvisation, the time, 20 to 25 minutes, 60 minutes, or whatever. The more data we have, the stronger our case can be. And the part about whether that's being used as a biomarker, I think is very worth exploring, because in the neurological rehabilitation, I don't know, it's quite kind of cutthroat. That if you don't show potential, or if you're, then you are sent home, and then you don't get all these therapies that you would otherwise have. And for patients who are not able to communicate, who have disorders of consciousness, whether they are in vegetative state or minimal conscious state, it is even more important to show that they are participating. And in this case, we have shown that during high heart rate synchrony, there's a lot of participation, there's a lot of awareness to the outside and things like this. So if we can use this with patients, when we are making therapy with patients with disorders of consciousness, maybe we can show from this way that the patient is actually participating, although we are not able to observe that they are participating. And that would have a very big influence on the trajectory of their aftercare, whether they continue to be in the hospital, or whether they will be sent to a long-term care home and receive no therapies. Yeah.
Thank you. Right. Are there any more questions from the audience? Alex Street secretly joined the panel unexpectedly, but now he is turned off his camera. So I assume he doesn't want to ask something.
I didn't turn my camera off. Leonardo turned my camera off. Thank you very much, Clement.
Oh, yeah, that's right. Sorry.
But clearly my microphone is working. I think the synchrony with disorders of consciousness is an interesting one, and it requires certain skills in the therapist and certain knowledge of how to make conditions favorable for any kind of heart rate synchrony. So I think Clemens mentioned breathing, and one of the components of the MATADOC, the music therapy assessment tool for detecting awareness in disorders of consciousness, does involve or can involve that playing of music, live music in synchrony with breathing rate, with the rising and falling of the chest, for example, which sometimes is quite difficult. So, I think, you're right. I agree, rather, that there's, various lines of inquiry, and the disorders of consciousness are certainly one of the populations that, are challenging to connect with, which is why the MATADOC came about. But also the other lines of inquiry and conditions, what happens when there's drumming? Is it are the two people instructed to perform in a certain way? And in terms of the thresholds for people receiving further funding to continue their rehab. They do have to meet certain criteria, but some of that is to do with the sensitivity, or rather the lack of any kind of really formal assessment tools, and the limited sensibility of some assessment tools as well. So heart rate could indeed play a part in that, couldn't it? In understanding the connection, but also then linking the therapeutic outcomes with that connection. Did it enhance those outcomes in any way?
Yeah.
Sorry, that was a whole load of response to what I was hearing, basically.
And I did not mention this a lot, but from the heart rate synchrony, it is also able to determine if during this heart rate synchrony, if the patient is leading or if the therapist is leading. This is also interesting because we can turn around and say, well, maybe it was not about the connection, it's just about the therapist being very good at following, you know. But in our study, we found that patients leading was significantly over the patient leading was more than the pseudo-synchrony. So it was interesting. And for the patients who are in vegetative state, maybe it would be even more interesting if we find that the patient was following, you know, instead of the therapist was following. Because therapist following, we can say, yeah, the therapist was looking at the heart, the breathing, and could follow. But when the patient starts to follow the therapist, that would be really quite amazing.
Yes, if there was a way of tracking changes in respiratory rate that were quite reliable, then yes, as you say, that could be, yeah, something could be worked out, couldn't it, to determine if there was a change in roles in that situation. Yeah.
Right, thank you. Sansan, there's one more question now in the chat. I don't know if you want to very briefly answer that. And the question is, how would you communicate or relate this into practice? For example, how would you describe to the wider MDT that someone is participating through potentially synchronizing the heart rate with the music therapist?
What is the MDT? What does it mean?
Multidisciplinary team.
Sorry, again?
Multidisciplinary team.
Okay, sorry, of course. Yes, I'm doing my best. I'm actually on the process of translating the MetaDoc into the German version. I'm leading the project with the expert panel. And after the translation, what I would do is we will be making a validation study across a German-speaking community that will be involving Switzerland, Germany, and Austria. And in this way, I would like to also tie in the heart rate synchrony and to match the observation from the MetaDoc DE and the heart rate synchrony. Yeah. And I'm giving a lot of tomorrow, for example, I'm going to another hospital and presenting. Yeah. So I will be very happy if you guys all help me to talk about this. And there will be a paper. This is still under review about heart rate synchrony at Frontiers, and so we hope that it will be published soon.
Yes, great. So yes, 32. So thank you very much again, Sansan, and thank you everyone for coming. And I'll hand over to Leo, who has some updates for our next research lecture and some other stuff. So thank you very much, everyone.
Thank you so much, Sansang and Clemens and Alex and all of you for joining us today. So next lecture will be about stroke, music listening for stroke recovery. It will be on the 15th of December by Satu Bailan. You can join the newsletter through the link I've just posted earlier, so you can be up to date for that. And again, the YouTube channel, you can join and subscribe it. We'll see, we'll confirm later if this lecture will be available there as well. Thank you for joining.